As a quick review, here are the Python data types we've seen so far. Int is for storing integers, and they are stored exactly. Float is for real numbers. You create floating point constants by adding a decimal, so remember 3 is an int and 3.0 is a float. Also remember that most real numbers cannot be stored exactly as floats. The division operator produces a float even if both operands are of type int. A list stores a sequence of values and is designated using square brackets with commas between each value. Strings are created with either single quote or double quotes. They must begin and end with the same quote character. The fact that we can use either character makes it nice when you want to use the other one as part of the string. If you want to use an apostrophe, you can begin and end the string with double quotes. Or if you want to include the double quote character, you can begin and end the string with single quotes. Chapter 5 of the book covers strings in more detail. In this video we'll learn the basic operations you can do with strings, and later videos will show you that strings have methods and how to use some of those methods. Here is an example string. Each character in the string has two different indices that you can use to access it. The first character is at index 0, and the last character is at 1 less than the length of the string. Note that spaces count as a character in the string. You can also access each character in the string using negative indices. -1 is the index of the last character, and negative the length of the string is the index of the first character. The length of the string can be found using the len function and passing the string as a parameter to it. Len of s would return 13. This shows some expressions using indexing and what each expression would evaluate to. In practice, we would either assign these to a new variable or use them as part of a more complex expression, but here we will just look at what each expression evaluates to as the comment shows. The square brackets are used to indicate that we want a specific index of the string, and the index is placed inside the brackets. We see that s bracket 0 and s bracket -13 would give us the first letter p, since 13 is the length of the string. S bracket 12, which is 1 less than the string's length, or s bracket -1 gives us the last letter. And to help you notice that a string contains spaces that take up positions, we note that both s bracket 6 and s bracket -7 give us the space here. Using the index operator produces a new string of length 1. We'll use the same example string and note that the bracket operator can also be used for slicing. A slice of a string is a partial sequence of a string. A slice contains 0 or more characters from a string. A slice is created using the bracket operator with a colon between the starting and ending indices for the slice. Note that like range, we don't get to the ending value, and when the indices are positive, the difference between them gives us the length of the slice. As with indexing, taking a slice produces a new string. Here are 3 examples. The slice from 0 to 2 produces py, the slice from 2 to 5 produces tho, and its length of 3 matches 5 minus 2. The slice from 10 to 13 produces fun. This shows that you can leave off the beginning or ending index when slicing. If you leave off the beginning index, it starts from the beginning of the string, as if you had started with index 0. If you leave off the ending index, it goes to the end of the string. Note that if you leave off both indices, you get back a copy of the original string. You can also use negative indices. Using 10:-1 starts at 10 and goes up to but does not include what's at spot -1. If you leave off the beginning index and go to spot -1, it creates a new string without the last letter. Note that you can also get an empty string. An empty string is different from a space. An empty string has length 0, while a string with one space has length 1. Python also allows you to specify an ending index that is beyond the end of the string and it will not crash. It just gives you as many letters as it can. Python also supports concatenation, which is also known as catenation. The concatenation operator is the plus operator. Note that the plus operator does different operations depending on the type of the operands. If the operands are numbers, it performs numeric addition. If both operands are strings, it performs concatenation. It is an error if you try to add a string and a number. Here's an example showing that we can concatenate 3 strings together using 2 plus operators. Note that spaces are not inserted. The strings are placed directly together. If you want a space between those 2 strings, you would need to concatenate a space between them. You can also combine slicing or indexing with concatenation. Since the expression s1 bracket 2:4 produces the string th, we can concatenate it with s2, which is the string is, and get this. The multiplication operator can also be used with strings. In this case, one of the operands must be an integer and one must be a string. When used with a string and an int, it is known as the repetition operator and produces a new string that contains multiple copies of the string operand. For example, both 3 times S3 and S3 times 3 would produce fun, fun, fun. You can combine string repetition with concatenation. Just as with numbers, the repetition operator has higher precedence, so we do each repetition and then concatenate the results together. Note that you can use repetition with a space to get a string containing that many spaces. Strings also support iteration. When you iterate over a string, the loop index variables assign one character from the string, and then the body executes. So when you iterate over a string, the number of times the loop body executes is the length of the string. We commonly use ch, which in this case is short for character, as our loop index variable when looping over a string, although you can use any legal identifier you want. This example shows that looping over a string and printing the character outputs one character per line. The first time through the loop, ch is assigned p, and then it prints it. The next time through the loop, ch is assigned y, and then that is printed, and so on. If we use end equals with a space when printing them, it would output each character on the same line separated by a space, instead of going down to the next line. We could iterate over the string and use the accumulator pattern to add 1 for each character, so when the loop ends, the variable length would tell us the number of characters in the string. So while this would work, if you want the length of the string, you should use the len function as we saw earlier. In this example, we did not use the loop index variable ch in the body of the loop. In most cases, your loop body will use the loop index variable, but as this example shows, not always.